right, so this is the second tutorials of Krok 1 Physiology base. Krok 1 Physiology base, the second part. All right. So we have the minute blood volume in a patient with transplanted heart has increased as a result of physical activity. What regulatory mechanism is responsible for these changes? So volume of blood has increased due to increase of what? Physical activity. So what are we looking at for? Of course, we are looking at for what? For catecholamines, or catecholamines. So what then is a transplanted heart? A transplanted heart is denervated, so no nervous stimulation can increase or decrease the heart rate of or the cardiac output. So when we say a transplanted heart is denervated, we are talking about what? A heart that has no nervous stimulation that can increase nor decrease the heart rate or cardiac output. So the only mechanism whereby your volume of blood can increase is when there's an increase in what? Epinephrine, norepinephrine, adrenaline, and non-adrenaline. Okay, non-adrenaline. So here we are referring to what? Catecholamines. And all of these are all catecholamines. So your answer is C. We have isolated muzzle of a frog. It's rhythmically irritated with electric impulses. Every next impulse is in a period of relaxation from the previous contraction. Again, every impulse is in a period of relaxation from the previous contraction. Okay, so what contraction is appearing over here? So definitely we have to call it tetanus contraction. We have to call it tetanus contraction, but there are different kinds of tetanus contraction or tetanus contraction. And what is a tetanus contraction or a tetanic contraction? This refers to what? A sustained muscle contraction that is evoked when the motor nerve that innervates a skeletal muscles emits action potential at a very high rate. I repeat, it occurs when there is a sustained muscle contraction. That means it's contracting like that without stopping. And this is due to what? Innervation of the muscles at high rate, at a very high what? Rate, at a very high rate, at a very high rate. So please take note. And it is differentiated into complete and incomplete. We can have complete and we can have incomplete. So my microphone is misbehaving. Guys, I'm coming. My mic is disturbing me. Okay, great. So like I was saying, this can be differentiated into what? Into complete and incomplete tetanus. Complete or incomplete tetanus. Now, in an incomplete tetanus, we also call it waved tetanus. So write it down. Incomplete means wave tetanus. Incomplete means wave tetanus. In some books, you will see unfused. So this is when the muscle fibers do not completely relax before the next stimulus. The muscle fibers do not completely relax before the next stimulus. Why? Because, of course, they are being stimulated very high. Great. However, there is a partial relaxation of the muscle fibers. There is a partial relaxation of the muscle fibers. So if you look at this question, for instance, you are looking at what? At an incomplete, because the next impulse is in the period of relaxation. That means relaxation is not complete, and then the next impulse comes in. So we have what? A waved tetanus, or an incomplete tetanus, or an unfused tetanus. Now, in a fused tetanus, we also call it holotetanus. Holotetanus. This is when there is no relaxation of the muscle fibers at all. No relaxation between the stimuli, and it occurs during a higher rate of stimulation. So again, in a wave or in an incomplete, there is what? Relaxation, but the relaxation is not complete. In holotetanus, there is no relaxation at all. So please take note, because we're going to meet them again. So here, we are referring to what? A waved tetanus. Waved tetanus. Okay, a man has a normal sensitivity of his finger skin. However, he doesn't sense his wedding ring around the finger. Of course, you see, something, if you're wedded new, if you put the ring there, you might feel that there's something there, but after some time, you won't feel anything. Okay, it happens to everybody, not just a ring, anything. So what it means is that your body has adapted to it, that this thing is here forever, or it has come to stay, and that is it. So it has come to stay. So here we're referring to what? A receptor adaptation. A receptor adaptation, because your body is now used to the ring, or the man's body is now used to the ring. It's used, so you will not feel that there's even a ring over there. You will not feel. It's just like ladies who do their hair, and they don't feel that they're even holding anything on their hair. Oh, I'm lying. Maybe I'm lying because I'm not a woman. So the answer is B. All right. So what do we have here? We have an aged man with high blood pressure under stress, guys, under stress. What is the cause? Of course, sympathetic system. Sympathetic system, because stress. So the answer is E. Stress. ECG showed T wave were positive, and I mentioned about the ions, right? The potassium, the calcium, the sodium. And I said in T waves, what comes to mind? We are talking about what? Ray polarization. ECG, T wave represent ray polarization. P wave represent depolarization. Represent depolarization. So please take note. QRS complex corresponds to what? Depolarization of the right and left ventricle. Of the right and left ventricle. Again, T wave is for what? Ray polarization. P wave is for what? Depolarization of the atrium. Then QRX complex is for what? Depolarization of the right and left ventricles. So please take note of that. So here we are referring to what? E. And we said in depolarization, what ion? Sodium. Please, sodium. In ray polarization, what ion? Plays an important role. Potassium. So please take note. The blood minute volume of a 30-year-old man at rest is 5 liters per minute. What blood volume is pumped through the pulmonary vessel per minute? They are saying that the volume at rest is 5. So definitely it's going to pump the same amount of blood inside systemic circulation, or inside the it's pumped through the pulmonary vessels. It's the same thing. Same 5. To be the same 5 for any given value. The same 5. The same 5. So blood minute volume is simply the amount of blood that is pumped out by each ventricle in 1 minute. Pumped out by each ventricle in 1 minute. So basically, it's the product of the stroke volume and the heart rate. Stroke volume and the heart rate. So basically, that is it. So if the volume is 5 liters per minute, then of course you're going to pump that same volume into the what? Into the systemic circulation. Into the systemic circulation. So it will be the same value. As a result of long-term starvation, the glomerular filtration of a man was accelerated by 20%. Okay, starvation. If you are starved, what happens? You don't eat. You don't eat. And they are saying filtration rate has what? Increased by 20%. That means you are excreting more. The most probable cause of filtration changes under such condition is because of what? So glomerular filtration rate or glomerular filtration is simply a renal process whereby fluid in the blood is filtered across the capillary of the glomerulus. Across the capillaries of the glomerulus. Fluid being filtered. And we said in the blood, what holds fluid? Yes, potassium and sodium. Yes, potassium. Hey, what am I saying? Potassium. Proteins hold fluid. Proteins and of course, sodium can also hold what fluid. So in the blood, we're talking about sodium and then proteins. But this person is starving. So it is more of what proteins that the person is what lacking. So there's low amount of proteins. What happens? That means there'll be what decrease in oncotic pressure. And when there's decrease in oncotic pressure, what it means is that fluid will leak out of the blood vessels. So edema can be forming. Great. So over here, we're talking about a fall of oncotic pressure. Fall of oncotic pressure because we're dealing with starvation. So starvation, that means proteins could be impeded or proteins are not coming. Now we have seen question on tetanus. In the course of an experimental, a skeletal muscle is being stimulated by a series of electric impulses. What type of muscle contraction will arise if every subsequent impulse comes in the period of shortening of the previous single muscle contraction? In the previous of what? Single muscle contraction. Single muscle contraction. This kind of questions, they are kind of complicated. So this one, you could have taken of what? Maybe you're thinking of a period of what? Relaxation. But they're saying that in every subsequent impulse comes in the period of shortening of the previous single muscle contraction. What it means is that there's no even relaxation present. No relaxation is present. So even as the thing is contracting, maybe it's about to go down, another contraction also come in. So the cell does not get the ability to relax. And again, we have explained the types of what? Tetanus. We said we have what? We have complete and we have what? Incomplete. So this one is what? Complete, also known as what? Holotetanus. And we say in holotetanus or infused tetanus, we are referring to what? No relaxation at all. No relaxation. So that comes to mind. No relaxation. So here is what? Is A. Here is A. Now don't forget that partial tetanus can also mean waved tetanus. I said it again. Partial can also mean what? Waved tetanus. So here we are thinking of what? Of holotetanus. All right. While shifting the gaze to the closely situated object, the refracting power of the eye's optical mediums will increase by 10 diopters. It results from the changing of such eye structure. So what then is a diopter? A diopter is a unit of measurement of the optical power of a lens. So it measures what? The power of a lens or a curved mirror. So basically, that is what it simply what means. So here we are dealing with what? The power of lens. Power of lens. The spasm of the bronchial muscles, the muscle of the bronchi develop in the patient. So that means that the patient is what asthmatic, right? Good. Usage of activated of what membrane cytoreceptors is physiologically valid to decrease this attack. To decrease this attack. So what are you looking for? So here you are looking for what? A beta agonist. Beta agonist. Beta agonist. Or bronchodilators. Bronchodilators. So for a bronchodilator, you could think of a salbutamol, right? Yeah, salbutamol could have been. So over here, we are talking of a beta adrenal receptors. Beta adrenal receptors. Beta adrenal receptors. Because it will lead to what? Relaxation of the smooth muscles. Smooth muscles. So the answer is D. Intrapleural pressure is being measured in a person. In what phase has a person hold his breath if the pressure is negative 25 centimeters of water? Negative 25 centimeters of water. Again, intrapleural pressure is being measured. So when we talk about pressure, it's the pressure that helps you to breathe in and breathe out. Because why you're able to breathe in and breathe out is because of the differences between what the pressure inside and the pressure what outside, or the atmospheric pressure. So they're saying that in what phase has a person hold his breath if the pressure is negative 25? If the pressure is negative 25. So you can write this down. If the pressure is 7.5, we are referring to quiet inspiration. You meet them, that's why I'm writing it down. Quiet inspiration. If the mercury, the pressure is 7.5, we are referring to what? Quiet inspiration. If it is 25, that's positive 25, we are referring to what? Forced inspiration. Forced inspiration. Forced inspiration. And if it is negative 25, we are referring to what? Speed of inspiration. We're referring to speed of inspiration. Speed of inspiration. Speed of inspiration. However, I'm still yet to understand a lot of so many things that comes to play over here, which I'm still trying to research on them. However, until then, just know that 7.5 is for quiet, 25 is for forced, negative 25 is for what? Speed of inspiration. So again, we're referring to what? Speed of inspiration. Speed of inspiration. So the answer is D. All right. We have an examination of the person. It was revealed a minute volume. Again, minute volume is what? The blood that is what? Pushed out of the heart. It's what? 3,500. Systolic volume is 50. What is the frequency of cardiac contraction? What is the frequency of cardiac contraction? If you remember, I said cardiac output is equals to what? Systolic volume times the heart rate. Cardiac output is equal to what? Systolic volume times the heart rate. So over here, systolic volume over here, the minute volume is there, which is same as what? The cardiac output. That's what? 3,500. The question is, what is what? Then we are referring to what? The rate. They want us to know the rate. So by your rate in mathematics, so make RA the subject. This is equal to what? CO over what? CO all over SV. So cardiac output is what? 3,500 all over, what is the systolic volume? 50. So 0 cancel 0, 5 into 35 is what? 7. So we have what? 70 beats per minute. 70 beats per minute. So what do you think of? Your answer is C. 70 beats per minute. All right. Due to activation of ion channels of external membranes of excitable cells, its resting membrane potential is significantly increased. That means it is more negative. That means too much repolarization. You know, repolarization means relaxation, right? So if it is significantly increase, the resting potential is significantly increased. That means there's what? Hyper-repolarization. And of course, what channels are activated? Of course, you know what controls it is what? Potassium channels. Potassium channels. Potassium channels. Potassium channels. So again, increased in the resting potential of an excitable cell is called what? Hyperpolarization. Hyperpolarization. It's controlled by what? By potassium. We have the ventral roots of 5 frontal segments of the spinal cord were cut during an experiment. What changes will take place in the innervation region? Now, the ventral root is responsible for what? Ventral root of the spinal cord is responsible for what? For motor innervations. Motor innervations. Or it controls motor and glandular functions. Motor and glandular functions. And if motor innervations are cut off, what it means is that there will be what? Loss of movement. There will be loss of movement. So here you are thinking of what? Loss of movement. Because they said what? The ventral side. The ventral side. Okay. So that is what? A. Ventral. Where glomerular filtration rate has increased. Again, it has increased. So that means that it has to do the problem with oncotic pressure. It has increased due to prolonged starvation. Again, same question in a different formulation. So what are you talking about? Of course, decrease in oncotic pressure. Decreased in oncotic pressure. If you understand some of these things, you don't need to worry yourself. So this one, 5 seconds and you are done. And you move on to the next question. You don't waste your time on it. A patient has a transverse disruption of the spinal cord below the 4th thoracic segment. What changes of respiration will it cause? What change in respiration will it cause? So first of all, you must understand that spinal cord injury will often lead to an impairment of the respiratory system. Again, spinal cord injury will often lead to an impairment of the respiratory system. Of the respiratory system, because it affects the bulbospinal respiratory pathway. It affects the bulbospinal respiratory pathway, which will, of course, will lead to respiratory paralysis or whatever you might call it. Now, but basically, regardless of the injury, the more it goes down, the more severe it becomes. The more it goes down, the more severe it becomes. So, in other words, the more rostral the level of the injury, the greater the likelihood that a major respiratory impairment will occur. So over here, there will definitely be a problem with respiration. But over here, they said respiration will stay unchanged, which is wrong. There will be a change in respiration. And if possible, it can even be arrested or it can even stop. In severe cases, it can stop. All right. So according to Krok, this is A. So we maintain it. But there will be a change. All right. Due to cranial trauma, the patient developed the symptoms intention tremor, dysmetry, adiodocokinesis, dysarthria. What structure of the brain is injured? definitely there's problem with what? With tremors, that means what? Shaking and all of those things. So usually when those things comes, we are referring to what? A problem with the cerebellum, because cerebellum controls what? Posture, equilibrium, and movement. Posture, equilibrium, and movement. And in this question, we're having problem with what? With ataxia, asthenia, intention tremor. We're having rebound phenomenon, dysarthria, and then adidokokinesis. All of these are all has to do with equilibrium, movement, and posture. Equilibrium, movement, and posture. So here you are thinking of cerebellum. Cerebellum. A lightly dressed man in a room. So underlined lightly dressed. Air temperature is plus 140 degrees. Windows and doors are closed. In what way does he emit heat most actively? In what way? You see, your doors are closed, your windows are closed, temperature is plus 14. So it is plus, not 140, it's plus 14 degrees. And then the room is, you are lightly what? Dressed. So in what way will heat be emitted? So this is what? Heat radiation. Heat radiation. And heat radiation is the transfer of internal energy in the form of electromagnetic wave. Heat transfer. So in the where the temperature is that cold, plus 14, is cold. It's actually chilled. It's chilled. So you need to produce heat inside yourself, internally. There's what? Heat production. Heat production should be there. And that is called heat radiation. Heat radiation. So basically, we're talking about heat radiation, whereby energy is produced in the form of electromagnetic what? Wave. And again, it does not really require a medium for its transfer. It doesn't require a medium for its transfer. And over here, the key words here, something you can see what? A naked or lightly clothed or lightly dressed. All of these are key points in knowing that this is a heat radiation. Heat radiation. Heat radiation. So your answer is D, heat radiation. I like ECG questions because you people are good with ECG. ECG of a patient with hyperfunction of the thyroid gland showed heart hurry. It is indicated by the depression of the following ECG element. Now, this means that there's what? Hyperthyroidism. So thyroid hormones increases activities of beta adrenergic receptors for catecholamines. They increase what? Heart rate, because catecholamines will be produced, so heart rate will be decreased, will be increased. It will be increased. An increase in heart rate always will show a decrease in the RR interval. In the RR interval. RR interval. So here we are referring to what? RR interval. Why? Because there's increase in heart rate. Increased in heart rate, because the heart is not able to get enough time for relaxation to move to the next part. So it just pim, 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 pim. So the RR interval will be actually what? Decrease. It's faster. It's faster. That's what's called heart rate. Increase in heart rate. RR. Don't forget your KRS. RR. They'll be shorter, and the more shorter they are, the more they are what? They are increasing. So think of what? We are thinking of D. Thinking of what? D. All right. I think some of you are just told us. So let me just, so this is what we mean. This is the P wave. So this is your R. Now in tachycardia, obviously tachycardia, what happens is that, so maybe this one will come here like this. Then before you realize another P wave will come, then another one will come, then another one. So it's just close to each other. But maybe on a normal day, it's supposed to be R here. But because it is tachycardia, there's even another R in between them. So it beats faster. And that's why the heart rate will be high. So the answer is D. That means the space here is decreased. That's what they mean. The space here, not the length. It is the space that is decreased. The space that is decreased. A peripheral segment of the vagus nerve. Guys, you remember vagus nerve? Vagus nerve. What does it do? Vagus nerve normally lead to what? Decrease in heart rate. Decrease in heart rate. So it was stimulated. That means heart rate will be decreased. What will happen in this patient? There will be a decrease in heart rate. What is it? So heart rate will fall. It's the same as decrease in heart rate. So your answer is D. Heart rate fall. Heart rate fall. Again, we are having prolongation of the T wave. What does it mean? It means there is deceleration in the ventricles of what? Of course, you are talking about what? Repolarization. Repolarization. So you understand some of these things. You don't waste your time. Don't confuse yourself with anything. They say prolongation of T wave. That means there's what? Repolarization. Now, in a healthy adult, speed of excitement conduction through the AV node is 0.02 to 0.05 meters per second. Now, AV delay enables what? So again, what is the function of what? The AV node. I think I've done a good job on describing all this blockage and all this reason why there's what? A delay in the AV node. So AV node is delayed so that what? The contraction can be effectively what? Distributed on the atrium and then the what? The ventricles. Right? So it can be effectively what? Distributed on the ventricles. So when it beats from the atrium, then it transfers into the AV node. The AV node will delay it a little bit, then fire it into the ventricles. So what it does is that we have to call what? A sequence of atrial and ventricular contraction. That is the reason for delay. But this is not as if there's blockage. This is a normal delay. In blockage, that means that there's no connection or there's an impediment of the flow of contraction. That's completely different from the normal delay. From the normal delay. So this is a normal delay, and this is to help in the sequence of atrial and ventricular what? Contraction. Atrial and ventricular contraction. So your answer is E. A child is showing concentration of calcium. Calcium is produced by what? Of course, parathyroid. Parathyroid. Sometimes you see the question, don't waste your time. If you see it, you will know. They've told you there's what? Lowered calcium concentration. So if it's lowered, of course, we're talking about parathyroid hormone because that's what controls what? Calcium production. And of course, if there's no calcium, it can lead to a convulsion. Simple as that. Now, look at it. I said something earlier on, but look at it. Heat transfer mechanism is the most effective. Sorry, so what heat transfer mechanism is the most effective while the man is being at 80%? That's what humidity. Humidity is what? 80%. 80%. Relative humidity is 80%, which is high. Temperature is what? Plus 35. It's not quite low. 35 is, though it's a little bit low, but of course, the moisture content is high. So again, you are thinking of what? Evaporation. I told you to take note of what? Humidity. And again, we are looking at what? Relative humidity. Relative humidity over here. All right. During preparation of a patient to a heart surgery, it was necessary to measure the pressure in the heart chambers, okay? In one of the pressure varied from 0 to 120 within one cardiac cycle. What heart chamber is it? Guys, what heart chamber is it? What heart chamber is it? Definitely, you know that this is the left ventricle. Left ventricle. At left ventricle, that's when it begins to pump into the what? Into the aorta. 120. And it's always common, 120. 120. Okay. That's not we have the systolic to be what? So this more like less like what like systolic. This more or less like what the systolic pressure. Systolic pressure 120. Okay. 120 systolic pressure. All right. Heart rate of a man permanently equals to 40 beats. Guys, 40 beats. I've already done it before. 60 to 80 is AV node. 59 to 40, you're talking about what? AV blockade. AV node. AV node. Then less than 20, you're talking about, sorry, less than 40, you're talking about His, and less than 20, you're talking about Purkinje fiber. So here we have what? AV node. AV, that's where the contraction is coming from. AV node, AV node, AV node. Again, look at it. They said stimulation of an excitable cell by the electric current has led to depolarization. What ion is involved in depolarization? Of course, potassium. Sodium. Potassium is hyper or repolarization. Repolarization. So the answer is what is E. You see what I'm saying? If you understand these things, you don't worry yourself. Patient of a 10-year-old boy consulted a doctor about extension of hair covering, growth of beard and mustache. 10 years, you're having a lot of hair, growth of beard, mustache, and low voice. Intensified secretion of what hormone are you thinking about? This guy is maturing very, very early. So we're talking about testosterone. Testosterone. So because these are what primary sex hormones. These are actually what primary sex hormones, and this patient is developing secondary sexual characteristics. Secondary sexual characteristics, and so therefore, testosterone will be what produce more. All right. Lung ventilation in a person is increased as a result of physical activity. Which of the following indices of external respiration is much higher than in a state of rest? Again, lung ventilation in a person is increased as a result of physical activity. Okay. Which of the following indices of the external respiration is much higher than in the state of rest? So first of all, during physical activity, you must know that during physical activity, all lung volumes tend to increase to meet up with the increased demand. So in that state, what happens? It means the whole respiratory volume is increased. The whole respiratory volume is increased. So here we are thinking of what? Respiratory volume. All right. A man took a quiet expiration, name an air volume that is meanwhile contained in his lungs. That means if you do quiet expiration, what volume is left in the lungs? What volume is left in the lungs? And that volume is called functional residual capacity. And the functional residual capacity is simply the volume of air that is remaining in the lungs after normal expiration. The volume of air remaining in the lungs. Now, in residual, it's the volume that is remaining in the lungs after forceful expiration. Forceful. So we have the residual, what is left, forceful. But the functional residual is what normally you breathe out. So normal breathing out, the volume present is the functional residual. But if it's forceful, you could be thinking of what? Residual volume. Okay. So your answer is A.